We'll look at the muscles of the neck in a lot more detail in Volume 4 of this atlas. Now we'll move on to look at the vitally important contents of the vertebral canal: the spinal cord, the spinal nerves, and the protective layers of tissue that surround them. We'll look first at a cross-sectional view of the vertebral canal. This is a cut through the 6th thoracic vertebra. Here's the spinal cord. It only partway fills the vertebral canal. On each side there are 2 lines of nerve filaments, one arising from the ventral aspect and one from the dorsal aspect of the cord. These filaments form the spinal nerves, as we'll see in a minute. The spinal cord lies within this strong protective layer, the dura. The dura is lined on the inside by a loosely attached membrane, the arachnoid. The cord is covered on the outside by a firmly attached membrane, the pia. The space between the arachnoid and the pia is called the subarachnoid space. In life, it's filled with cerebrospinal fluid. The space between the dura and the wall of the vertebral canal is called the epidural space. It's filled with fat, loose connective tissue, and blood vessels. To see the contents of the vertebral canal from end to end, we'll take a look from behind at a dissection in which all the laminae have been divided along these lines and removed. Here's the sacrum. Here's the base of the skull. The tissues that occupy the epidural space have been removed to give us a clear look at the dura. This is the dura. The sleeve of dura is called the dural sac. It's open at the top end and closed at the bottom. Here, at the base of the skull, the dural sac passes through the foramen magnum, becoming continuous with the layer of dura that surrounds the brain. At the bottom end, within the vertebral canal of the sacrum, the dural sac tapers down to a point at the level of the second sacral segment. To look at the spinal cord, we'll divide the dura in the midline and lay it aside. Here's the spinal cord. In the early embryo, the spinal cord extends the whole length of the vertebral column. But as development progresses, the vertebral column grows much more rapidly than the cord. The cord ends up filling only the upper 2/3 of the vertebral canal. The lower end of the cord, in the adult, is at the level of the first lumbar vertebra. Let's see some more details. These are nerve roots. We'll look at them in a minute. The cord is attached to the dura by a series of fine triangular ligaments, the denticulate ligaments. To see how the spinal nerves arise, we'll go up to the cervical region. The denticulate ligaments have been divided. Each spinal nerve arises from a small bundle of dorsal filaments, which unite to form the dorsal sensory root of the nerve, and a similar bundle of ventral filaments, which unite to form the ventral motor root. In the cervical region, the nerve roots follow a slightly oblique downward course. In the thoracic region, their course becomes more oblique. Here, right at the lower end of the spinal cord, this continuous line of nerve filaments gives rise to a large number of nerve roots, which run vertically downwards, almost hiding the very end of the cord, which is here. Below this point, the dural sac is occupied not by the cord, but by this leash of vertically running lumbar and sacral nerve roots, the cauda equina. The nerve roots leave the vertebral canal, 2 at a time, all the way down to the lower end of the sacrum. Let's follow the course of one spinal nerve as it passes from inside the subarachnoid space
to its emergence from the intervertebral foramen. To see this, we'll look at the cervical spine in a dissection in which all the surrounding muscles have been removed and in which the laminae have also been removed, along these lines, as in the previous dissection.
Here are the roots of the nerve, leaving the dural sac. Here's the nerve, emerging from the intervertebral foramen. To see the whole course of the nerve, we need to remove this part of the vertebra. Here's the dorsal root of the nerve. Here's the ventral root. The sleeve of dura that surrounds the converging nerve roots merges with the outer layer of the spinal nerve. This thickening at the very beginning of the spinal nerve is the dorsal root ganglion. The spinal nerve passes forward and laterally to emerge from the intervertebral foramen. To see that more clearly, we'll go back to the preceding stage of the dissection. As the spinal nerve emerges, it divides into this small posterior primary ramus and this much larger anterior primary ramus. The posterior primary rami of the spinal nerves pass backward to supply the muscles and skin on the back of the body. The anterior rami pass forward and laterally to supply all the rest of the body. This anterior ramus is an unusually large one.
It's one of a set of 5 large rami between C5 and T1, which form the brachial plexus. The major nerves to the upper extremity emerge from the brachial plexus. The anterior rami from L1 to S3 are also large. They form the lumbar and sacral plexuses, which give rise to the nerves for the lower extremity. These plexuses are shown in volumes 1 and 2 of this atlas. There's a man-made puzzle that we need to clear up regarding the numbering of the spinal nerves. In the cervical region, each spinal nerve takes its number from the vertebra below it. But from T1 on down, each nerve takes its number from the vertebra above it. The result is that there's one nerve, the one that emerges between C7 and T1, for which there's no corresponding vertebra. It's called C8.